Okay. So we weren't able to create the features using the pandas TA library in our previous step. The likely reason for this is that the library is quite old and thus might be a bit outdated and might not be fully compatible with the latest version of NumPy. So let's ask Gemini to fix it by using a different library. Now, I've logged out of the previous session, so I don't have my last conversation in the history. That means I need to give Gemini some context about what was working and what wasn't. You might not need to do this if your workflow is different. Once I provide all the necessary information, I'll wait for Gemini to adjust the code, and hopefully, this new version will work properly. Fingers crossed. And there it is, our fresh new code. Let's then check what we have here. So at first, Gemini tells us that the problem we encountered is a classic sign of an older library not being compatible with NumPy, and it decided to replace the pandas TA library with the Finta library. Cool. You can read more of what it had to say on the matter if you'd like. Meanwhile, let's check out the Finta library on the PyPI repository. And there we have it. Now, it looks like it's even older than the pandas TA library, but hey, maybe that won't matter, and it'll still work. What do you think? Anyway, Gemini shares a few more thoughts about the Finta library and asks us to install it. So, let's go back to our notebook. Okay, before we install Finta, let's first run the code that was previously working for us. That means connecting to Alpaca and fetching the data. Cool. It still works. So, let's install the Finta library now. Wait for it. And there we have it. So now we can replace the feature engineering code that used pandas TA with code that uses Finta, and hope for the best. As you can see, we import Finta here as TA. We get some additional explanation about the code we already pasted in the previous cell, so there's no need to paste anything else here. And now let's see what we have in our create features Finta function. First, we make sure the required columns for some indicators are present. Then, we calculate features like the simple moving average, exponential moving average, relative strength index, moving average convergence divergence, Bollinger Bands, and ATR. And finally, we check if BTC data exists and contains data before running feature engineering with the Finta library. If everything is in place, we lowercase the column names, create a copy, generate features, and print a preview. Otherwise, we get helpful messages and avoid errors by creating an empty fallback data frame. So now, after one last check to make sure we have everything we need, we can run this cell and see if our features are actually calculated. And it works. We've got our SMA, BBL, BBM, BBU, BBB, BBP, ATR, and returns after 1, 3, 5, and 10 minutes added to the table. That's amazing. Gemini, you did good. I think I can hire you as my assistant, if you're looking for a job. Okay, anyway. Now we can paste the second version of the code provided by Gemini. This version includes everything, both the newly generated code and the parts that were already working, so we get the full solution in a single cell. The only thing we need to do now is paste in our API key and secret key so we can connect to Alpaca. Let me find them real quick. If you're not sure what they are or how to get them, you can check out my previous tutorials. And it's done. Now, let's clean it up a little. Then, we can run the code to see if this version works too. And it looks like it does. It's fetching the data. And there we go, we have our data frame with all the data and calculated features. We even get the column names in the featured data, which is nice. We didn't get that in the previous version, so I guess Gemini must have changed the previously working code we provided. That's okay this time, but it's always good to check for changes like this before running new code. Of course, if you're using tools like Cursor, Windsurf, or something similar, you might be able to see exactly which lines were changed. But here, since we're working with the online chatbot version of Gemini, we don't get those highlights. Okay, anyway, the code works. Great. Thank you, Gemini. So that's our full working code for now. And now we can move on to the next step, creating a machine learning model, defining target and training the model. So let me copy and paste what we had before from Gemini. And let's ask Gemini, giving it all the previous code, to adjust the code based on the changes we made in the feature engineering step. If you want, you can read through Gemini's thoughts on the matter and analyze the output step by step. But for now, we'll just wait for the full answer and use it without diving too deep into the details. Let's copy and paste the answer Gemini provided. And actually, let me tidy things up a bit so I know exactly where everything is. Keeping your notebook clean and well organized is always a good habit. It saves you a lot of headaches later on. If you're working with AI like I am here, it's also helpful to include the prompts and the AI's answers as comments or markdown cells. Those can be really useful when you revisit the notebook, helping you remember why you made certain decisions or how you got your results. Plus, after taking a break, whether it's days, weeks, or even months, a clean and well-documented notebook makes it much easier to pick up where you left off without getting lost. So, don't underestimate the power of good notebook hygiene. And finally, let's copy the code for our adjusted step 4. Alright, so here's what this code does. First, it prepares our data for training by creating a target column, basically checking if the price goes up after a few minutes, and labeling that as 1 or 0 if it doesn't. Then, it cleans the data, drops unnecessary columns, and splits it into training and test sets without shuffling, which is really important for time series data like this. After that, we train an XGBoost classifier on the features we created earlier, and if everything goes well, we get accuracy, a classification report, and even the top 10 most important features. The code also includes a bunch of helpful checks to make sure the data isn't empty, the right columns are there, and that we don't run into any nasty surprises during training. Super useful when you're building something step by step like this. We'll talk more about it in the next part of this tutorial. In the meantime, let's also copy and paste Gemini's final notes about the key changes and considerations for this part of the code. And that's it for now. And now that we have the code, we can go ahead and run it. In the next part, we'll take a look at whether it actually worked. Of course, you can run it yourself. You'll find the notebook on my site. That's all from me for now. I hope you enjoyed this part, and I'll see you in the next one. Oh, and remember, improve yourself, improve your business, improve the world, but also, live and have fun. Yours, Super AI.